Okay, so this is the 12th question, right? 11th, we have done 11th questions.
11th.
Oh, 11th one is to be started.
Yeah, I think from 11.
Okay, let me see. Yeah, 10th we are done. 11th is what? Yeah, can I see the 11th question then? 11th question. Tan theta plus cot theta multiplied by sin theta cos theta equal to 1. Okay.
Yeah.
Okay. So the 11th. Question tan theta plus cot theta multiplied by sin theta cos theta equals 1. This is what we need to prove. Okay, simple. I think go with the sine over cos and cos over sine. Okay, substitute for tan as well as cot. So that becomes sine theta over cos theta plus cos theta over sine theta, and just open the brackets. You don't need to do LCM or whatever, just open the bracket because one of these things get cancelled actually.
Oh,
So when we open the bracket, then becomes sine theta divided by cos theta times or multiplied by sine theta cos theta plus cos theta over sine theta multiplied by sine theta cos theta.
yeah.
So this gets cancelled here and this gets cancelled here. So you're left with sine square theta plus cos square theta, which is 1. Yeah, as per the identity 1. Yeah.
No, so can you go back to the first slide where you show the identity?
Okay.
Like
Yeah,
we
yeah,
wrote down
sure,
there.
sure, sure, sure. We'll go to,
So I don't know that.
no problem, no problem. This is the thing, and this is the thing, right? This is the one we wanted. Sine square theta plus cos square theta equals 1. Yeah, yeah, yeah. So this is actually posted on YouTube already.
Okay.
Yeah, I posted it. Yeah. So immediately I do it because I delete from my system.
Okay.
Yeah, so that it doesn't use my computer space. So it's there on YouTube already, but you can note it down. Not an issue. Yeah.
I didn't get the.
Oh, I see. So this is what we have, and now go back to the first screen, isn't it? I mean, the where we are doing 11th question. So this is the. So we have done that. 11th is done. Okay. Now 12th one. 12th one, he says two-sided identity, meaning you have one here and this in turn equals to this. Okay, so you have cos theta. You can start because this is the simplest one. Okay, it's very difficult to start from here. You start from here, the middle one, prove that that's equal to cos theta, or start with the last one, prove that that's equal to this or whatever. I take the last one. Okay, cot theta divided by square root of 1 plus cot square theta. So I use the 1 plus cot square theta, this identity for this. That's nothing but cosecant square theta, square root of cosecant square theta. That's the third one. Yeah,
Yeah.
I think third one. Yeah. So then the square root and the square will give me, it's a cot theta over cosecant theta, which is the middle one. So that's this one. So you have this. Now we have to prove this in turn equals cos theta. So I take this and I substitute, like cot theta equal to cos theta divided by sin theta, that is for this, and divided by cosecant is 1 divided by sin theta. So that's the easiest actually, sin theta. Yeah, yeah, that's it. So then this gets cancelled, so you got cos theta. So choosing actually where to start, sometimes in the identity where to start is important. Obviously this is the simplest. Cos theta is the simplest out of all the three. So if you start from there, then you have to do some multiplications, divisions, and some way of coming out. You multiply by sign, divide by sign, then you get caught. Like that you can prove also. But yeah, this is the better way.
Can you explain that one thought again? That how that cos theta became
Huh,
cos
this one,
yeah.
right? Yeah, this
Yeah.
one. So the numerator is this. This is the numerator, cos theta over sin theta, and this division symbol is this. Okay? This division symbol is this, and for cosecant theta, reciprocal is this. Okay, yeah. So this entire thing is this.
Okay.
Okay, and this is this.
Okay.
So the division symbol is this. Yeah. Okay. So now the next one, you can see that there is a to the power of 4. That means some algebra simplification is to be done first before we do any identity choice. Okay. So sine to the power of 4, sine to the power of 4 theta minus cos to the power of 4 theta. So we try to get this into an algebraic form. That's why we write this as a sine squared theta whole squared minus cos squared theta whole squared. So if you assume this entire thing is a squared minus b squared, so this is a. So you got a squared squared, b squared squared.
Okay. Oh, okay.
Okay, yeah. So we look at this part only first. That means this entire thing, if you assume this as a p and this is a q, you have p squared minus q squared. So we write that as p minus q times p plus q, or p plus q times p minus q. P is a squared, q is b squared. Okay, so you get a squared minus b squared multiplied by a squared plus b squared. Now we come back. What is our a square? A square is nothing but sine square theta. Sine square theta minus cos square theta, and this is sine square theta plus cos square theta.
Does it become 1?
Yeah, this is 1.
Yeah.
Yeah, correct. So that's how you got the sine square theta minus cos square theta. So the next one is 13th question. Oh, 13th is what we did, right? Okay, that's wrong. This one, this is not 12th, this is 13th. So we need to have the 14th one. 14th one is secant square theta plus cosecant square theta. You are adding them, comes as a multiplication. Okay, so secant square theta plus cosecant square theta equals secant square theta. Okay, it's easy. So write this as a reciprocal. That means 1 divided by cos square theta plus 1 divided by sin square theta. Clear, right? Understood. This is 1 by cos, secant is 1 by cos. Yeah, cosecant is 1 by sin. So still on the left side, so you just take the LCM, which is cos square theta, sin square theta. You just multiply them denominators. So this times this, so you have sin square theta plus cos square theta, so which is equal to 1 divided by cos square theta multiplied by sin square theta. So this 1 gets divided to both, so it's 1 into 1. Okay, so that means you will get 1 by cos square theta into 1 by sin square theta. Yeah, so yeah, Correct, correct. So secant square theta to cosecant square theta. So proved.
So okay, so
Yeah.
you not okay, you just convert it.
Yeah, yeah. That's it.
If you just leave it
Like
one
this,
one
like
by
this.
one,
Yeah.
is that the fine or like they asked to do
No. Yeah, you have to do this.
that?
Yeah, this is must. Okay. Because if they ask you simplify or whatever, then we can stop here. The moment you say show that, prove this identity, then you have to come to the end.
Okay.
Okay. So let's go to now the next page, and I think further questions we need, right? So up to 14 we have done. So from 15 to, yeah, hello, back, hello, can't hear you, hello,
Hello? Hello? Hello?
yeah,
Yeah. Oh, sorry. The speaker got muted. I couldn't hear you.
okay, now,
Okay. Now I can hear you.
yeah, because I'm hearing myself, it's going all the way to you and then coming back, going back to me.
Is it better now?
Yeah, now it's clear. Yeah.
Okay.
So now we are back to, okay, sharing is done, gone, right? Obviously.
Yeah.
So share application, this is the one, start sharing. So you see the screen?
Yeah, I can see.
Yeah, okay. Okay. So this is a formula to be used for 15, algebraic simplification. That is a formula which, just like the way we have a squared minus b squared formula, for this there is a formula called a cube plus b cube equals to a plus b to a squared minus ab plus b squared. So this is the top formula we'll be using. Here a is equal to sine theta and b equal to cos theta. So substitute that, then you have sine cube theta plus cos cube theta equal to sine theta plus cos theta.
Fine.
No, this is a plus b.
Oh, okay.
Okay.
So
Yeah.
reading the second one.
Yeah. Second one is sine square theta minus sine theta cos theta plus cos square theta. So this no change, and this becomes 1. So sine theta plus cos theta. So you have 1 minus sine theta cos theta. Done.
Oh.
Yeah, this is together 1, right? This and this.
Why one?
Sine square theta plus cos square theta is 1.
We can take it out.
Yeah, you can organize them, right? So that's 15. Okay. 16 sine square phi, that letter is phi, bracket 1 plus cot square phi. These questions are very simple. I think page 2, I don't know, some questions are really very simple.
Yeah.
Yeah. Sine
You
square.
said today he was just like going to the basic again. But he went back to low or something because some people have some doubts. So it means that he'll finish that tomorrow and then he'll take Trig for like 2 more class.
2 more for this entire thing, this sheet
So
works.
tomorrow we finish up loads
Huh.
again.
Oh, I see. Okay.
Wednesday and then Monday he'll do trigonometry if he can finish.
Okay. So sine square phi 1 plus cot square phi, we need to show this is equal to 1. So this is the only complex stuff. So we need to substitute for that or look for the identity together. So this actually is a third identity, identity 3. You get as a cosecant square. So this is cosecant square phi with the third identity. So now put this as a reciprocal sine squared phi multiplied by 1 by sine squared phi. So this gets cancelled, leaves one answer, 16. Got it, right? Yeah, so this is the third identity. In the first sheet, if you see 1 plus cot square something equal to cosecant square, this is the identity. So we substituted that. So cosecant is a reciprocal of sine. This is a reciprocal identity. Okay. And so sine square get cancelled. That leaves 1. Right? Yeah. So 17. Tan a plus cot a whole squared. Obviously, we need to do the opening the bracket, which is a plus b whole squared. Yeah, expand. Yeah, correct. Tan squared a plus cot squared a plus 2 tan a into cot a. So that's equal to tan a into cot a is 1 because both are reciprocal to each other. So you get tan squared a plus cot squared a plus tan a cot a, as I said, 2 tan a into 1 by tan a. So this gets cancelled. So you got 2 here, right? The 2 will be split. The 2 will be split into 1 and 1. So we take that 1 plus tan squared a, yeah, 1 plus tan squared a plus 1 plus cot squared a. So use the identity 1 plus tan squared a is the secant squared a plus 1 plus cot squared a is cosecant squared a. So that's how the 17 is done. Any question?
Yeah.
Makes sense, right? Okay.
Yeah.
Understood?
Yeah.
So now we'll go to the next one, 18th. So secant to the power 4 minus secant square equals to tan square plus tan to the power of 4. Okay.
So for the power 4,
yeah, we have secant to the power of 4 theta minus secant square theta equals to tan square theta plus tan to the power of 4 theta. This is what we have. So that's 18th. So simplify on this side actually. So we can write secant to the power of 4 as secant square theta to the power of 2 minus secant square theta. Okay. So only this we changed. Okay. Only secant to the power of 4. Now between these two, secant square theta is the common. We are pulling out secant square theta. When you pull out secant square theta, here you will have one more secant square theta remaining minus 1. Okay. So then keep this as secant square theta. This one, as per the identity 2, it becomes tan square theta. Okay. That becomes tan. 1 plus tan square theta equal to secant square theta. So modify, yeah, you modify the form, and 1 plus tan square theta is secant square theta. Therefore, secant square theta minus 1 is tan square theta.
So what is secant square theta minus 1?
Okay.
That's tan square theta.
Tan square theta.
Okay.
So we'll go to the first page.
I think he missed out. I think.
Ah. Oh, really? Okay.
Yeah.
So here, see, we put that as secant square theta minus tan square, the second one, right? So you bring this, I haven't written fully. Yeah. Here, we can bring that, there are three use as is. Now coming back to the modified one, right? So if you write the modified here, the modified one will be secant square theta is 1 plus tan square theta, or secant square theta minus 1 is tan square theta. These are the modified things. Here also you will have modified 1 plus cot square theta equal to cosecant square theta, or 1 plus cot square theta, or cosecant square theta minus 1 equal to cot square theta. Same thing but modified, you know. It's a formula, it's the same formula. Yeah. See, I told you that day, right? It's better we remember from the one perspective, what and all we get 1. And this has a difference, you know, secant square minus tan square, cosecant square minus cot square. And from here you modify the version and then take it. Okay. So that's the one we used. So we have secant square theta multiplied by tan square theta. This identity to modified. So
I have that the other one, like the one that you just showed. That part he gave, right?
Yes, correct. Oh yeah. It's true. That's what I told you the other day. Normally in the textbooks, right, they'll give you this. Yeah, they'll give this form. Textbooks and teachers, everyone, they talk about secant square theta equal to 1 plus tan square theta and 1 plus cot square. This one they do. Okay. I put that as a 1, right, because everything is coming 1 1 1. Okay. So I actually teach in that way, saying that you better remember this modified form itself. Okay. And then you can get that thing, the other one, by making a subject, different one as a subject. Okay. So fine, I think either some people say this is here. Yeah. Yeah. So that's what I wrote actually here. If you see, second one is like this, I said, but then I would differ this way. Okay, note it down, no problem. Yeah, sure. here.
Yeah.
So like this is the first one, second one, and the third one. Okay. So this one, right? The one means this one. Whenever you see one, the number one can be, okay. So this is what I mean. One can be replaced. So either one or two or three, depending on what are the other. Yes. So in that I was explaining, because that's the most common way of actually trick, to identify whether to substitute something for one or not. That's why you remember this formula, and first option is use as is, left to right. That means if this is given, if you see this, understood, right? If you see this in the question, straight away replace with 1. If you see this in the question, straight away replace with 1. If you see this in the question, straight away replace with 1. That's the first means, use as is, left to right. The second one is, it could be right to left. One is there, that's what I mean here. Right to left is, this is what the right to left. Whenever one is given, try to replace that with either sin square theta plus cos square theta, or secant square theta minus tan square theta, or cosecant square theta minus cos square theta. That is the second level. The third level, which is a modified one, you are making subject. If you need tan square theta is to be replaced, this is the subject. That's why cos square theta is taken to the other side. This is the one. Here cos square theta is made as a subject. Okay. Same way here, secant square theta is made as a subject. Tan square theta is made as subject. Something. Okay. So the subject is different. That's what we call as a modified one. Otherwise, right to left and clear.
So if you basically make something the subject, then
yeah, correct. That becomes modified one. Correct. That's it. Yeah. So we are at secant square theta multiplied by tan square theta. Okay. But then here we only have entire thing in the tan square. So we write this again using the same identity as 1 plus tan square theta.
1 plus tan square.
Yeah, that's the same formula, modified thing, right? 1 plus tan square theta multiplied by tan square theta.
Okay.
So then open up the bracket, so multiply like that. So you get tan square theta plus tan to the power of 4 theta. So we proved that's what is required.
Tan square theta, we can't simplify that.
No, this is same as this, right? This is same as the right hand side. Yeah, that's the right hand side. Okay, so then 19th question is cosecant theta minus sin theta. Wow, this is a lot. So I better take this and then put onto the next page. So 19th question, cosecant theta minus sin theta, secant theta minus cos theta, tan theta minus plus cot theta. So much of things going on here. So everything is reciprocal to each other. If you see this, cosecant theta is reciprocal to this, secant theta is reciprocal of cos theta, tan theta is reciprocal of cot theta. Yeah, so see, sin theta and cosecant theta, they are reciprocal.
Okay, they are.
Same way, cos theta and secant theta are reciprocals.
Okay.
And yeah, tan theta, reciprocal means one by the other. Okay. Either way I can remember that way, or multiply you both of them, you get 1. You multiply this, like,
Oh, you multiply.
Yeah, like tan theta, tan theta and cot theta equal to 1.
Okay, to get that.
Yeah, you can do that. That's what the reciprocal mean.
Oh yeah,
Okay, reciprocal means you have product of two things. Okay, product of, for example, product of A and B equal to 1, that implies that A and B are reciprocal to each other. Reciprocal to each other.
Okay, yeah, makes sense.
Yeah, that's how they use the word reciprocal. Now, so we need to substitute, and we go with the simplest. That means we replace with the sine by cos, cos by sine, like that. Okay. So we write this as 1 by sine theta minus sine theta, and then bracket. This one is 1 by cos theta minus cos theta. The next one will be sine theta over cos theta plus cos theta over sine theta.
These are basically the reciprocals.
Yeah, we just substituted the reciprocals or the formula for each one of them.
Okay.
Now this entire thing will come back as, note this one, first one can be, you are taking the denominator as sine theta, and numerator will get 1 minus sine square theta for the first one. This is sine theta by 1, right? This is cos theta by 1. Okay. Yeah, this becomes 1 minus cos square theta divided by cos theta.
What did he say?
No, second one. Yeah, the second one. Third one would be, you have sine theta cos theta, cos multiplication sine square theta, yeah, plus cos square theta. Correct. Yes. So now using the identity 1, this 1 minus sine square theta becomes cos square theta. That's making subject, cos square theta as a subject, divided by sine theta into sine square theta divided by cos theta, 1 divided by sine theta cos theta. Okay, so this cos theta and this cos theta together cancels with this. This sine theta and this sine theta together cancels with that. So you got the answer as 1.
What is the question?
You have to prove that as 1. Right side, 19th question, right hand side is to be 1.
Yeah.
Next one is the 20th question. Can you try? So cot A is equal to sin A, cos A by sin A. Yeah. So just need to substitute. For cot it is cos by sin. For tan it is sin by cos. Then simplify.
So same for the denominator.
Yeah, similar to the denominator, and then you will see something like, this is a famous thing. I should tell that. Oh, this is 18th one, and this is the 19th one, is it? Okay, so yeah, I'll swap them. 19th one, I'll first swap them and then we'll come back. So okay, now so this is the last one, and we go to this. So what I was trying to say was, we have cot A, yeah, that's the one. So whenever you have in algebra, like you have something like A divided by B whole divided by C, like this. If at all you come to this kind of, this is one fraction and this is another fraction like this, then the answer is simply AD by BC. AD by BC. So remember that, okay, because it will be useful. This way also you can remember. Otherwise, you go ahead and first simplify the First simplify the numerator.
That is to simplify AB.
Yeah, numerator. Okay. Simplify the denominator separately. Okay. Then this could be 1 and this could be 2, and then just say 1 divided by 2. Okay. So yeah, try it. You finished already? You did it? No. Okay. Do that. Hmm. So which step, up to what step you have come?
Like after the LCM.
Okay, so can you see the board?
Yeah.
Okay, so see which step you have.
Yeah, after
This one.
Show the mouse.
This one.
Yeah, after that one.
Okay. So done.
After the I didn't get that part. I think that the part where you can cancel.
This one.
Yeah, that's
Yeah.
it.
So we use this formula AD by BC. So A is this, that is this. Okay. D is this. So we put that D here. AD. B is this. C is this. Because both are same. Cos A cos B plus sin A sin B.
Oh, okay.
So exactly same. So identical. So we cancel them out.
Okay. Okay, then I get cos A by sin A
into yeah, correct.
Yeah.
Then that's the answer. Okay. So the next one also is simpler, means you can do actually. You just take LCM and then do the cross multiplication, do the a plus b whole square. That means 1 plus cos alpha whole squared sin square alpha plus 1 square. So you will get it. You try it. Yeah. Yeah, simple, very simple. Oh, we need to prove that it is 2 cosecant alpha. The question is this. We have to prove that it is 2 cosecant alpha. Okay, good. You got good. So the next question, we have to come from right hand side. 1 plus 1 by cos A (1 plus 1 by cos A) equal to tan squared A divided by secant A minus 1. So pick the right hand side and substitute the tan equal to sin by cos and secant equal to 1 by cos. So you have tan squared A divided by secant A minus 1 equal to sin squared A by cos squared A divided by cos A minus 1. So remember, we have to get this also. First is that we have to look at the denominator. So that becomes cos A 1 minus cos A, and the numerator is same, sin squared A. Yeah, exactly, good. This is A, this is B, this is entire thing C, this is entire thing D. So AD divided by BC. So A is sin squared A, D is cos A divided by BC, cos squared A into 1 minus cos A. Okay. So we have cos squared A is down below, B is this, C is this, and so combine the things you combine. So that becomes tan squared A.
But here you don't take the A, B, C, D.
We have this is B, but then it is better to, in the answer you have got tan squared. So
yeah,
okay, so you go ahead and then 1 minus cos A.
Okay.
So this part is a part. Now we have to look at the cos A. Okay. Cos A, you have to write it as 1 by secant A. 1 by secant A divided by 1 minus cos A. Means the secant A comes to the bottom, secant A into 1 minus cos A. Now open the bracket. If you open the bracket for this, this one, right, secant A, open this,
How much time? 1 hour class is over. So do we limit to 1 hour today? Huh? Yeah, because no other topic he started, right? Yet. Hmm? Yeah, yeah, yeah. So we will end the class now and I'll make it as 1 hour only, right? Okay, right, Ranjit. Yeah. Morning.